This type of equation is something you never tackled at school, and it's also something they never taught you. So in this video, I'm going to show you how to solve such an equation. In this problem, we have to find all real numbers x satisfying the following equation. And it's also a question from the Korean Mathematical Olympiad, so let's go. Now, how can we try to solve this equation? The smart thing, which we might try to do, would be to substitute the 4 with the power of 2, 6 with 2 to the x times 3 to the x, and also 9 with the power of 3. And this is exactly what we're going to do. We see 2 to the x and also 3 to the power of x is something we cannot change because it's irreducible. But we can change the 4 to the power of x to 2 to the power of 2 times x, and we do the same thing for 6 and also for 9. Following on, the next smart thing to do would be to make a substitution. It is really useful, especially in this case, because the second equations basically contains only 2 to the power of x's and also 3 to the power of x's, so it would be smart to make the substitution. And as a consequence, we get a new equation: a plus b minus a squared plus ab minus b squared equals to 1. So we basically created a new problem, and in order to tackle this new problem, I'm just gonna rewrite the equation so that we get a term equals 0. And what is curious in this case is that if we look at the different terms we have a, we have a b, we have a times b, we have a squared, b squared, and 1. And these are all terms which always come while calculating, for example, the square of a binomial. And because of that, we're going to try to rewrite this equation as a sum of different binomials. And what we're going to do next is multiply by 2 and rewrite the whole term. If you see carefully, we just rewrote minus 2a squared and minus a squared, which is basically the same thing. And we also did the same thing with 2b squared. And if we continue with this trick, you might also have noticed that the first part is basically a binomial, or makes us think that this is binomial. And this also applies to the second part and to the third part. And because of that, we're just going to factor this expression. From the minus a squared minus b squared plus 2ab, we get a minus parentheses a minus b all squared. So you can see that these two terms are basically the same. These two also, and these two also, not calculating the 0. But now we have a problem. If we observe these 3 parentheses, these 3 terms, we can see that they are all squared numbers, and we know that square of a number is bigger or equal to 0. But because the equation should equal 0, then it means automatically that every one of these terms should equal 0. So a minus b should be 0, a minus 1 should be 0, and also b minus 1. But because of that, we have a unique solution, which is that a and b are 1. And because of that, 2 to the power of x and 3 to the power of x are 1. Hence, x equals 0 is the only possible solution we get in this case. And this is something they never told you at school.